Hello, this talk is about digitalization of the steel construction, where I'll present to you our most recent development. I would like to acknowledge my co-authors, especially Joaquim Norberto Pires, who has been the driving force of this work, and sadly, he left us this week, and it's a great loss for all of us. Now, what about Industry 4.0 in steel construction? We have had several examples of application of new technologies in steel construction or in construction in general. A few weeks ago, we had installed the first 3D printed bridge, steel bridge in the Netherlands. Previously, we had work from Arup, where they shown how a conventional piece can be optimized and executed using this new technology. We have the digital fabrication in Zurich, where they also try to incorporate the robots in construction. And we also have several examples of 3D printed concrete structures. We do also have building information modeling and digital twins, which allow us to have the three-dimensional model of the building, help interaction between the different specialities, and help avoiding problems in this interaction. This is also very useful at the construction site, where the teams can see how things can be executed, and this can be coupled with virtual reality, which is already available. For example, from Trimble, where you can see the progress, on-site progress of your building using this virtual reality and augmented reality. We do also have the possibility of parametric modeling, where we can easily change the length and height and whatever parameter we would like in our model, and in this way optimizing the solution, or if you say introducing changes at any time of the process. We also have available several optimization softwares, which allow us to find the best shape of that we need. And all these technologies together can really bring a big step forward in what is our reality right now. However, construction still lacks automation, and there are several reasons for that. One of this is that we're working with flexible geometries. Each building is unique. It is a tailored solution, and it's the whole process is built around that. This building, it also changes its location, so it can be built anywhere around the world. So these two together make it really impossible to compare, for example, with automotive industry, where there is a certain location where you produce the same product several times. So this is a really big difference in for automation. Another problem is that construction is a large scale product, and the current technologies may be not applicable to this scale. And also, since it's a tailored solution to the requirements of the investor, many times it is we have last minute changes, and we need to be flexible to respond to these changes. And if we have a production line which is doing all the same, doesn't fit with these last minute changes. So we believe that additive manufacturing can help solve some of these problems, since we can produce as much as we need. This can help to reduce the energy to produce the piece, and it can help to reduce the scrap, because we can produce as much as we want. Since it's automated production, it can improve quality. And as you know, when we have large scale and complex metal parts, for example, complex steel joints, uh, since they are mainly fabricated manually, this requires more supervision and more effort in that. However, there are problems associated to challenges to the adoption of additive manufacturing at its current state, namely what are the material properties and how exactly we're going to produce our parts. So this has been our motivation, and here at the University of Coimbra, we have created an additive manufacturing lab where we try to respond to these challenges. And what we have been developing is a novel workflow where we want to have a single step of design to final product procedure, which ensures quality, productivity, and economy. This design process will includes existing software products for the design and modeling of our piece, as well as for its automatic production and production control. An important part is the quality control, where we believe that it should be ensured by constant communication between the different technologies that are involved in this process, and also through validation with a database which stores data of previous attempts. And this is done for having in mind wire and arc additive manufacturing for steel construction. And as an output, we would like to have a prototype and a database which has this relevant for production information. So here is our workflow chart, where we have all these stations and they are all linked together. Here the CAD and modeling station refer to the design process, whereas the production control and hybrid system refer to the execution of this piece. And here we have a real system, and the production control is ensured through a digital twin that is exactly the same as the real system, and it is used to anticipate problems, to see how the piece will be produced, and avoid trial and error, repetitions, and loss of material. So what we have two robots. One is for wire and arc, and the other one is for LMD. At this stage, we are focusing on the wire and arc. However, it is intended that both will use the same software and work exactly at the same process that was shown before, with the different process at the end. So here we have the ABB robot that is placed on a linear track of 5 meters so that it can cover large areas suitable for steel construction. We have welding tables on top of which we produce our pieces. And for the wire and arc, we use welding machine furnace with the cold metal transfer process, which has been proven to be more suitable for additive manufacturing due to the lower temperatures. And here there is a demonstration of the digital twin and the real system. As you can see, they work exactly the same. We can, as previously mentioned, the digital twin is used to anticipate problems. It can work simultaneously with a real system. It can also work faster so that we can see what is happening, and we truly believe that this is a sustainable way of producing so that we can only produce when we need to do that. And our current focus is on two objectives. One is to characterize the material properties so that when we go to the design stage, we know what is the material that we are dealing with. And the other problem that we're trying to focus, objective, is on the complex geometries where this is associated to the robotic movement and what is the best optimum way to achieve a complex shape. So in conclusion, I'd like to mention those several possibilities for automation that exist in currently and for steel construction. Maybe we are not yet there, but for sure everybody is interested in the digitalization, and we're going in this direction. And we believe that additive manufacture has great potential for this future application. And now, ready for the Q&A part.